And now let's take a look at example 5 here. It says limits of power functions at infinity. So if we're looking at a function that has an even power, and then we have an even power, what happens is if you look at the limit as x approaches infinity, it will be going up to infinity. And if you go the limit as x approaches negative infinity, the function will also approach positive infinity. Why? Because an even power, if you approach infinity, will be infinity on both sides. It'll go, as you go right forever, it'll go up forever. As you travel left forever on this function, it'll go up forever as well. And it'll increase without bounds. So that's why if it's even and you're taking the, if your power is even and you're looking at the limit as x approaches infinity or negative infinity, you will have the solution positive infinity. However, if you look at a negative power, it'll make an S-curve, which means as you go left forever, it'll go travel down forever. Or as your x increases forever towards positive infinity to the right, it'll also increase to the right. And so that's if it's odd. So now let's take a look at this idea. It says here that if p be a polynomial function that's written in standard form here, then the limit of this polynomial function p will be the same as the limit of the greatest power, the leading term, and which we kind of learned about this in way back when in lesson, 2.4, 2.3, something like that, chapter 2, way back when. All right, so here, if I'm trying to solve for this limit here, what I can do is I can say that the limit of this function here will be equal to the limit as x approaches negative infinity of the leading term, which the leading term happens to be 2x to the 4th power. And any graph or any function that has an even power means it'll be kind of parabolically shaped, at least it's in behavior. And so as we go left, we can see that this graph does go up forever. So the answer would be infinity. So this limit will be the same value, the same answer as this limit here. I guess I could write it all in. Now that does not mean that 2x to the 4th plus x cubed minus 7 equals 2x to the 4th, but it does mean that the limits will equal one another. The limit of this function will equal the limit of the second function I wrote here, the leading term. Those two would equal each other, which does equal positive infinity because the graph looks parabolic. Looks like a parabola. Okay, on part B, this limit right here would be equal to the limit of the leading term as x approaches a negative infinity of the leading term. The leading term is the highest power term, which is x to the 5th. Now x to the 5th, since it's odd, will be shaped like an S-curve. And so as we go left, this function goes down forever without bound. And so the answer would be negative infinity. What am I doing? Negative infinity. As the graph travels to the left, the y values fall. As x values go left towards negative infinity, the y values fall without bounds, so they approach negative infinity. Here's another one. As we look, as x approaches positive infinity, this would be equal to the limit. Again, not to say this function is equal to the function, what I'm about to write for the leading term, but the limit itself will be equal. This limit and this limit will be the same of the leading term. The leading term is x cubed. So again, I'm looking at a graph that looks like a S-curve. And as I travel right forever, the graph increases without bound. So the answer here would be infinity. That would be our answer to this graph here, or to this limit. And so now here's one for you to try. Pause the video if you need more time.